course, DMAC assessment. The year is coming to a close rather quickly. Only 2 months once we get back, 8 weeks. All right, standard 20. So we focused a lot of our efforts on integration by substitution. Standard 20 focuses on a couple of other useful integration methods. We're going to look at first what's called integration by parts, an integration method called integration by parts, and then some methods to help us integrate some higher order multiple trig functions, integrations of trig functions by a couple of different methods here. Integration by parts is first up here for standard 20, first on the docket. I call it IBP for short, integration by parts, or IBP. It's just the reverse of how we took the derivative using the product rule. Integration by parts is just the complete reverse, the complete opposite, using the antiderivative from how we differentiated according to product rule from first semester. So product rule helps us take the derivative of the product of two differentiable functions in terms of x. How do I differentiate function u times function v? So they're kind of a song for it. The first times the derivative of the second. What's the second times the derivative of the first? For that, product rule is first times d second plus second times d first. So using that u and v notation, the derivative of function u times function v is u times the derivative of v plus v times the derivative of u. The first times the derivative of the second plus the second times the derivative of the first. Of course, we're talking about antiderivatives, and like I said, this is just the reverse. Integration by parts is the reverse of that aforementioned chain rule. So if I differentiate if I take the antiderivative of what I just differentiated, I basically derive where integration by parts comes from. The integral or antiderivative of the derivative of u times v, when I combine that antiderivative with the derivative, just cancels out, right? Giving me u times v. The antiderivative or integral of uv prime I bring down as the integral of u dv, u, the derivative of v given by dv here. The integral or antiderivative of v du, bring down the v, u prime I replace using du. To get to a more workable form, from what I have here, uv equals integral of u dv plus the integral of v du. To get to a more workable form, I solve for u dv. I want to solve for this portion of the formulation. Let's solve for u dv. I have to get rid of adding v du in that case. So to get rid of adding v du, I just subtract from either side. The antiderivative of u dv equals u times v minus, when I bring it over here to the left, minus the antiderivative of v du. There's your IDP formula. Integration by parts. The antiderivative of u dv equals u times v minus the antiderivative of v du. When you're trying to find the integral using integration by parts, you're going to assign your antiderivative a couple of different pieces. I need to know what the u portion is and what the dv portion is. What do I call u? What do I call dv? So here are a little bit of kind of rules of thumb, general thoughts on what to say is equal to u and what to say is equal to dv. U is the easier part to differentiate. If I have u, I need to find what du is in order to use this IDP formula. So if I want to assign u and then take the derivative of that to get to du, it would be best to call u whatever is more easily differentiable. Once we know what u is, I have to find du, so shouldn't I call u the easier part to differentiate since I have to take the derivative anyway? Makes sense. Okay, what's the rule of thumb for saying what dv is equal to? dv is going to be the easier part to integrate, because if I know what dv is, I would also need to know what v is. dv is the derivative of v, so if I have dv and when I want to find v, I have to take the antiderivative or integrate it. So shouldn't it make sense to let dv be the easier part to integrate? Because if I need to get to v from dv, I have to integrate it anyway. slide this over here. Oh, now I think we're ready to go here. We've got from integration by parts. It says that the antiderivative of u dv equals the product of u and v minus the antiderivative of v du. So let's apply it to a couple of basic antiderivatives. What is the antiderivative of x cosine x dx? U should be the easier part to differentiate. dv should be the easier part to anti-differentiate. Let's let u be assigned to the x portion in x cosine x. U equals x. The remaining portion, cosine x dx, will be given as dv. I know u is x. What's du in that case? What's the derivative of x? 1. So 1 dx. If the derivative of v is cosine x dx, work backwards, take the antiderivative to figure out what v should have been. If the derivative of v is cosine x dx, what's just v going to be the same as? Sine. What function would have a derivative of cosine? Should that just be sine? Okay. Now I just need to plug and chug. The antiderivative of u dv is equal to u times v, x sine x, minus the antiderivative of v du, so sine x dx. I've got two different terms here. One of them is pretty much finished up. X sine x, that's all done. I now need to subtract off the antiderivative of sine x dx. What is the antiderivative of sine x? Negative cosine. So if I subtract off the negative cosine, it would just be a positive. Right? Plus cosine x plus c. Of course, if you wanted to check your work, what could I do to my answer, my antiderivative? I wanted to check to make sure that this was the true antiderivative and the true answer. Take the derivative, and what should I get back to? X cosine x. So let's just do that. Let's take the derivative of x sine x plus cosine x plus c, just to be sure that it works out to x cosine x, what I started with. Okay? How do you differentiate x times sine x? What rule do we have to apply? Product product rule, right? Which makes sense because isn't integration by parts just the reverse of product rule? So I should need product rule to check my work. So if we check by differentiation, I'll first apply product rule to take rid of x sine x. So first times the derivative of the second, x times the derivative of sine x, or x cosine x, minus the second sine x times the derivative of the first, which is just 1. First times the derivative of the second is x cosine x, minus the second sine x times the derivative of the first, which is 1. Now take the derivative of the next term. What's the derivative of cosine x? This would be plus here. I'm sorry. First times the derivative of the second plus the second times the derivative of the first. What'd you say though, Dustin? Is the derivative of cosine x. The derivative of a constant doesn't matter. I don't need to bring out anything for that. Once I got the signs right, first times the derivative of the second plus the second times the derivative of the first, I gotta make that plus for this to work out. What happens to sine x and negative sine x, these last two terms? Cancels out, and what do we end up with? Which is what we should start with, right? Basically, what happens in integration by parts is I need this extra term on the end to cancel out what I'm adding by using product rule. Because product rule is first times the derivative of the second plus the second times the derivative of the first. So minus v du, this extra portion from the integration by parts, basically is going to be the exact opposite of what I would have added here to balance it back out again. That makes sense. Questions on using integration by parts so far? Let's try another one. X e to the x dx. Integration by parts is really helpful when you have an algebraic function paired up with a different type of function. So I have an algebraic function x and the trig function cosine x. I have an algebraic function x here paired up with, multiplied with another transcendental function, e to the x, this exponential term here. Really helpful using integration by parts to find these given types of integrals. All right, so you tell me, what are u and dv going to be given as? Agree with that? You really got a 50-50 shot at it. It doesn't work one way. Try mixing them around, right? Either u is going to be x or u is going to be e to the x, so you really got 50-50 go at it. If u is x, I guess the other part, e to the x dx, has to be dv. So we can just get that pulled down here. Let's see. U is x, dv is e to the x dx. So I just need to figure out what the corresponding du and v would be. Let me do the du here, Cheney. If u is x, what is du equal to? What's the derivative of x? So 1 dx, right? If dv is e to the x dx, what would v be, Caitlin? Yeah. Which function has the derivative of e to the x? Wouldn't that just be another e to the x? Because the derivative of e to the x is another e to the x. Or the antiderivative of e to the x is similarly e to the x as well. Now let's just pull this on through here. Integration by parts says take u times v, so x e to the x, minus the antiderivative of v du. So e to the x dx. First term to bring down is done. What do you think, Maddie? Minus the antiderivative of e to the x dx, so minus what, really? Minus e to the x plus. Should be good to go. You feel like trying one? Seeing a couple here. Have a decent understanding of it. Let's do a definite integral. X sine 3x, definite integral from 0 pi over 6. Definite integral from 0 to pi over 6 of x sine 3x. If I worked it out right earlier today, it should be 1/9. Find your u and dv. Set up your integration by parts and go from there. Questions online, guys? Lincoln, Hunter, how you looking?
Good.
I'm doing good.
Okay, we're just going to try this here for about 4 or 5 minutes. What is the definite integral from 0 to pi over 6 of x sine 3x? Yes. Justin, what do you think u and dv both are?
U would be x. dv would be sine 3x.
Now let's figure out what v and du both are. Du is obviously 1 dx, as we've used before a couple different times. I know it needs to be cosine 3x. What should I have out in front? So that the correct derivative of cosine 3x is sine 3x. Close. That derivative would be 3 sine 3x. Because I also have to multiply by the extra 3 according to the chain rule here in the middle. So I need to get rid of multiplying by 3. So let's multiply by because now that derivative, I think, works out right. If you take the derivative of negative 1/3 cosine 3x, it's negative 1/3 times negative sine 3x. times 3. The double negatives, like you said, canceled out. I like how you had the negative the first time. But you also need the 1/3 so that it cancels out multiplying the extra 3 by the chain rule.
Oh, so instead of like how we did last time, put it like 1/3 d of dx.
Set up more time.
So instead of like having it with the du like we have been doing previously, now it's with like the v.
U is still equal to x, but dv would be sine 3x dx.
Oh, yeah.
Right? Is that what we're seeing here?
Yeah. So that's gonna be 1/3.
It's a 1/3 now because of this extra 3x here, right? If I didn't have the 1/3, taking the derivative of v wouldn't get me to the right dv down below. Is that reasonable?
Mhm.
Chain rule says you have to multiply times each derivative. The derivative of sine is negative cosine. The derivative of 3x is 3. I don't want 3, so I need an extra 1/3 to balance that back out consistently enough. And your derivative of 0. Justin, you guys get started here? Find one way. What I've helped Justin and Caitlin get set up here is picking the correct u and dv adjusted. If I let u be equal to x and dv be equal to sine 3x dx, the other part of this expression, that's going to help me get set up for using integration by parts. Once I know what u and dv both are, I know what v and du are. If u is equal to x, du is the derivative of x, 1 dx. Does that make sense?
Yeah.
If dv is sine 3x, I have to take the antiderivative of that to find v. What function has a derivative? dv. What function has a derivative of sine 3x dx? Well, I know it's got to be cosine 3x, obviously, right? Well, the derivative of cosine 3x is negative 3 sine 3x. This is just sine 3x, not negative 3 sine 3x. So put an extra negative 1/3 out in front. So when I take negative 1/3 times the derivative of cosine 3x, it's back to sine 3x. You need to plug in 0 and 5 and 6 in, right? It's a definite interval. So evaluate the same derivative when x is 0 and x is 5 and 6. So let's see here. 2 times v times u cosine 3x is sine 3x. Positive. So all you have to do now is plug in 5 and 6 and plug in 2. Sorry, give 1/3 of it's b du. You see why you did an extra 1/3 there? Obviously, I know it's going to be cosine 3x. You see where that part comes from? So the derivative of cosine 3x would be negative sine 3x times 3. The extra 3 comes from multiplying by the derivative of 3x, right? Well, I don't want negative 3 sine 3x. I I want positive 1 sine 3x. So what constant do you have to have out in front so that the derivative works out to be the correct one? Negative 1/3. Switch the sign and get rid of the extra 3. Right? Find your antiderivative. I've got most people set up to here. Negative 1/3 x cosine 3x minus the antiderivative of v du. So negative 1/3 cosine 3x dx. Find the antiderivative and evaluate it for what x is pi over 6 and x is 0. This part here. All right. So then work through that second antiderivative on the last term. What is the antiderivative of 1/3 cosine 3x? What's the antiderivative of cosine? Just be 1/3 sine 3x. Would it not?
Yeah.
Since we're trying to evaluate the definite integral, evaluate it at 2 down to 0, 6. Hey guys, I'm just kind of helping some people here on this last question. Is there anything I can do to get you guys pointed in the right direction?
No, I'm good.
I've got some of the work started up on the
I
board.
just have a little bit left.
Okay. Okay. Maybe another minute here, and then we'll just kind of put everyone's thoughts together as we work through it as a class. Can, if you'd like to. Need a marker check?
I got one, thank you.
Never mind.
Can I have a marker, please?
Sure. You're just over on the sill here, on the ledge. Negative 1/3 x cosine 3x. What's the antiderivative of cosine 3x? Sine 3x, but I need an extra negative 1/3 out in front. So I'll bring down plus 1/3 sine 3x. Antiderivative of cosine 3x is sine 3x. I need the extra 1/3 so that it works out. So cosine 3x would be sine 3x times 3. I think I need a 1. I need another 3 out here. 1/9. Did you see the 1/9 there now? Okay. What is the derivative of sine 3x? What is the derivative of sine 3x? Times 3. What times 3 makes a third? Because I need to have a third out in front here. Right now, this derivative would be sine 3x times 3. I need it to be 1/3 out in front. So what times 3 makes a third? 1/9. Check my differentiation. The derivative of sine 3x is cosine 3x times 3. 1/9 times this extra 3 makes the third we had up in front. Let's evaluate this at 0 and pi over 6. Negative 1/3 times pi over 6 times the cosine of 3 times pi over 6. 3 times pi over 6 would be pi over 2. Plus 1/9 times the sine of 3 times pi over 6, that's pi over 2 again. Now plug in 0. Negative 1/3 times 0 times the cosine of 3 times 0, which is 0, plus 1/9 times the sine of 3 times 0, which is 0 again. Let's simplify the top expression, simplify the bottom expression, and then just take the difference. The cosine of pi over 2. Negative 1/3 times pi over 6 times the cosine of pi over 2. But the cosine of pi over 2 is simply just 0. 1/9 times the sine of pi over 2. But the sine of pi over 2 is simply just, no, it's not 0, it's sine of pi over 2 should be 0 plus 1 or 1. We got that part figured out. We're going to subtract when I evaluate the antiderivative for when x is 0. Negative 1/3 times 0 times cosine of 0. I don't really care because what that's got to be. I don't really care what cosine of 0 is because this should always be sine of 0 is 0. Sine of 0 is 0, so 1/9 times 0 is 0. 1/9 times 1. I had a 1/9 here times 1. That's that. Sorry, Justin, that was my fault. Sine of pi over 2 is really just a 1, so I have 1/9 times 1, which is just 1/9, right? Find the difference there. 1/9 minus 0, which is 1. Did I clear up any issues, problems as you're working through that?
Solve the 1/3 pi over 6.
1/3 pi over 6. Right here?
Like all of that equals 0. Yeah.
What's the cosine of pi over 2? So negative 1/3 times pi over 6 times 0,
We just-
it's just 0, right?
Yeah.
I didn't catch this part. What's the sine of pi over 2 here? This was my mistake.
Oh, yeah.
Sine of pi over 2 is
Yeah.
1. I saw the 1, but then I forgot I had the 1/9 still up in
Yeah.
front, right? So 1/9 times 1 is really just 1/9.
Yeah.
I was looking at that. The bottom part worked out nice because 1/3 times 0 times cosine 0. I don't even care what cosine 0 is, it's just 0. So anything times 0 has to be 0. What's the sine of 0 though, Caleb? 0. So 1/9 times 0 is 0 anyway, too. It's just 1/9. A lot of those